Hi, I'm Sean Gannon, and this is Minute Math. And we got a fun math problem here. We want to find the radius of our small circle. Now, what do we know about this figure? We have three circles here. They're all touching each other at tangent points. Tangent point right here on the line. Okay, they're all touching that, touching each other here. And one circle, the large one, has a radius of 4, and the other one has a radius of 2. So before I go dive in on how to solve this problem, I want you to pause this video and see if you can figure out the radius of the small circle. But again, like always, if you're impatient, we're just gonna dive on in. All right, let's get some label points here to help us out. Let's go call this point A, where the circle touches the line, and we have B here, and then C on the third one, A, B, C. Easy peasy lemon squeezy. Now let's go label the circle centers. I'm gonna call this one M, and let's call this one N, and this little one here is called that P, circle P. All right, so let's kind of get a baseline of really what we're looking at here. We want to find the radius of the small circle R, and let's call that length R. Now, if we know from the center of the circle down, that's going to be equal to the radius. If I can draw it here, and let's go call that R, that length R. All right, now this is where it gets kind of cool. I'm going to do the same thing with circle N. I'm going to deal with the big circle for the moment here so we can see a bigger picture of what's happened, and we're going to apply the same process to circle N. Draw a line straight down right here to the point of tangency on the line below. Okay, draw a line, ba-da-ba-ba-ba, draw a line. All right, and then from there, we know that this overall length is 4, right? And it's gonna be perpendicular, key, to the line here on the bottom. Point of tangency happens with circles. Got it? All right. From here, here's the fun thing. We're gonna make some triangles. I'm gonna draw a line straight across here. Okay, if I can make it straight across using my little level and ruler here. From circle P over to this line we made. All right, MC. And again, same idea, tangency right here. Relative radius, that's gonna be a right angle as well going on with that. The way we drew the line straight across also gives us little right angles here. Lovely, lovely, lovely. Got a nice little rectangle there. Let's get some more points. What did I call this? I call this point D here. And then P is a circle, so we're good to go. All right, now watch this. What is the length of MC? Well, MC, that length, is equal to 4. But MD is that length of 4 minus the radius, minus R. Ooh, we're getting some equation or expressions here to help us out. That's gonna be lovely. From there, let's go connect P and M together. Having a blast with it all here. Boom, 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 boom. With that, what do we got? Well, these intersect here, or we touch right there, these two circles, and it's going right through the touching point. And so we actually can refer to length of PM. PM is the length of this radius plus 4 that goes with it. So our radius of PM is P to this point, and then that point to M, that has a radius of 4. This radius of big circles 4, little circles R, and we have an R, or 4 plus R is the length of PM. All right, well, what's the length of PD? Don't know what that bad boy is, but we have a good old Pythagorean theorem that can help us out here. A squared plus B squared equals C squared. Let's go call this length here A, the length of AD. So A squared plus B squared is gonna be a 4 minus an R, all squared, equals the C squared, which is right here, which is a 4 plus an R. It's the whole length of PM. And we have 4 plus an R all squared. Let's go simplify this bad boy out here. A squared stays as it is. 4 squared, 16, minus 8R plus R squared is equal to 16. Oh, that's gonna be nice and cancel. Can you feel it? And we have an 8R, actually it doesn't cancel, but it's all right. Plus an R squared. All right, what can we cancel here? What do we got? The 8R's are gonna cancel. I'm feeling that, yeah. Oh, no, they don't. 8R stays the same. Don't do that. We got an 8R. See, I mixed it up. See, be careful with your negatives and minus signs. All right. I'm having too much fun. 16s cancel, r squares cancel, and what we're left is bring the 8r to the right, and we have an a squared is equal to a 16r. From there, just double check my notes. I want to get a by itself. Let's get a in terms of r. Square root both sides. A equals square root. Don't worry about the negative. Can't have a negative value here. And we have 4 square root of r when we take a square root of both sides, in case you want to see that. So we got an a value here, which is 4, if I can write that, 4 square root of r. Pretty cool, pretty cool, pretty cool. Now, I'm gonna do the same exact thing to the second circle. Oh, while I'm here, note, PD, same length as BC. That's gonna come into play in a minute, so bear with me. All right, same idea, second circle. We're just gonna flip everything over from here. So again, I'm gonna draw a line straight down from circle N down to center N to A. Let's go do that. Bada boom, bada bing. We're gonna draw a length, across here from P to that point. Don't erase stuff, Sean. You gotta make sure it's parallel for the floor. That's good enough for government work. From there, we know that's gonna be a right angle. This is a right angle here. Again, we're right angles across the board here. We're gonna draw a line again from N to P. And like I said, we're just repeating the same process over and over again, keeping it real. All right, bear with me. When I label that point here, reference, I called it E. Good old E, good old letter E. What do we know? What do we know? Same idea. The length of the radius N to A is 2, so N to E is a 2 minus that R, 2 minus R, right? That length being R right here. Then N to P is radius of 2 plus R, so we have a 2 plus R here. And P is equal to 2 plus R, and we want to find what is EP, question mark, which we know, going through, because we have a rectangle, is the length of AB. Eventually we'll get that. Good old Pythagoras, again, helps us out. Let's go break down, oh, we got nice here, circle that. All right, let's call, I call that A, let's call this length B here, length B. A squared plus B squared equals C squared. So with that, we have one leg is a 2 minus an R squared plus B squared is equal to C squared, 2 plus R, all squared. Let's keep it fun here. Foiling this out here, that's gonna be a 4 minus a 4R plus an R squared plus B squared equals 4 plus 4R plus an R squared. All right, hopefully you know your multiplication out here. Distributive property, keep that in mind. All right, hopefully I can cancel this better. 4's cancel here. The R squareds cancel. Let's go add a 4R to both sides, and we have a B squared is equal to an 8R. Square root that, let's get B by itself, and B is equal to 2 square root 2R, I believe. Yeah, 2 square root 2 times, oh sorry, square root of R. There we go. 2 square root of 2 times square root of R. And that is our length of B. I can't really fit it in here. Let's put it here. 2 square root 2 square root R. That's what it can simplify to be. And that is also equal to the length of AB. Let's go put that down here. 2 square root 2 square root R. And here we have 4 square root of R. All right, so now here is the kicker. We don't just have one right triangle here. We don't have 2 right triangles. We're gonna create a third right triangle, and again, use the Pythagorean theorem. Where do we get this triangle from? Well, here we go. I'm gonna call this point here F. What do we know here about this point F? Well, it has the same height as M, right? Diameter of the circle is 4, radius of this one's 4. We got the same height. Let's go draw this. If I did it correctly, it should be more or less good enough for a light board math here. Draw that across, bada boom, bada bing. Looks pretty good for me. Write that here. Then I'm gonna go across here down. Connect here, the other side of that radius, we know it's gonna go down. We know that's gonna be a perpendicular right here because it's a tangent line right here. Circle's perpendicular tangent, boom, boom, got it. Draw N now to M. Triangles are our friends here, people. Triangles are our friends. Go like that, bada boom, bada bing. We're having so much fun and learning. All right, we got a right triangle here. What are the values? What do we know? Well, this has a radius of 2. We got that. We don't know the length of NM. Oh, we do. How do we know that? That's 2 and 4 together gives me good old 6. So we have NM is equal to 6. We have FN is equal to 2. What about FM? What is FM? What is that equal to? Well, that's equal to the sum of AB plus BC, and we got that in terms of R. Let's look at this bad boy. That's gonna be a 2 square root 2 plus a 4 square root R. Oh, square root of R. Oh, did I forget that? No, it's down here. All right, there's an R there. So length of FM is a 2 square root of R plus a good old 4 square root of R. And Pythagoras is gonna help us out here. Hopefully I have enough room. If not, I might skip a step to get an answer here. But what do we got? Pythagorean theorem, a squared plus b squared equals c squared. We got 2 squared plus a other leg, this whole bad boy here, that 2 square root of R plus 4 square root of R, all squared, is equal to a 6 squared. And look at this, we have an equation now that just has one variable, and we know with that, we can solve for R. All right, 2 squared is 4. I'm gonna save you some time here. That simplifies this whole little inner thing. What did I simplify it to be? That's gonna be a, oh, I am doing decimal. All right, so it becomes a 2 square root 2 plus 4, all squared with an R on the outside there. Just kind of put that out there, equals a 36. If you want to do that time simplifying, you can do it, but I think you're just skipping ahead. Anyway, 4 comes over to subtract to both sides, so that gives me a 32. And this whole bad boy is a decimal, is a 46.6274 R. This is approximate now, folks. We divide that 46.6274 to both sides, and we get R by itself here is approximate. Again, keep it approximate, Sean. It's not exact, 0.6863 right there. If you want the answer as far as a square root, or if you know the answer in square root, put it in the comment section below. But either way, our radius here for the itty bitty tiny circle is 0.6863 approximately right there. Did you get that answer? If you did, way to go. And if you like this video, make sure to like this video, share this video, and subscribe to our YouTube channel. This helps us make, well, more of these fun math videos for you and for everyone else. So, as always here, thanks for watching.